This video is for activity set 8.2. We'll do multi-stage probability experiments and compute theoretical probabilities. We start by talking about the roulette wheel, which has 36 compartments, half red and half black, and 2 green compartments. Once red came up 32 times in a row, and the probability of that is about 1 in 4 billion. When you're done with this activity set, see if you can find that theoretical probability on your own. It's actually not hard. The probability of 2 or more events occurring is called a compound or multi-stage probability. And when they don't affect each other, they're called independent events. If they did affect each other, they were called dependent events. So let's look at an example that we can really take apart. Consider the probability of randomly drawing 2 red tiles from a box containing 3 red tiles and 4 green tiles. On the first draw, the probability of obtaining a red tile is 3/7. If you put the first tile back, you replace it before the second draw, the probability of drawing another red tile is still 3/7 because we still have the same number of tiles. These two drawings are independent events because the first result doesn't affect the outcome of the second draw because we put the tile back, so we still have the same number of tiles. We can describe this by drawing a probability tree. And you see this has a lot of branches. So let's make sure we understand this tree by looking at it in pieces. First, we draw our 2 branches for drawing a red or a green tile. There are 3 red and 4 green tiles, so the probability of drawing a red tile is 3/7 and the probability of drawing a green tile is 4/7. Now we draw the second stage of branches, and since we put our tile back, those probabilities remain 3/7 and 4/7. So we have our tree, red-green on each option, 3/7 and 4/7 on each option. Now we read off the branches to determine our probabilities. The top level of branches is red-red. The outcome is 2 reds, and that probability then is 3/7 times 3/7, or 9 out of 49. In the same way, the bottom branch is green-green, and that probability is 4/7 times 4/7, or 16 out of 49. Now, to get a green and a red tile, you have to look at the 2 inner branches, because of course the order doesn't matter. If you just only care that you have a red and a green tile when you're done, then green-red and red-green both get you that result, and you add those probabilities. 12 out of 49 plus 12 out of 49 is 24 out of 49. Notice that when I add all these up, the probability of 2 reds, the probability of 2 greens, the probability of a green and then a red, plus the probability of a red and then a green, that adds up to 1, which is good. The probabilities in my sample space, everything adds up to 1. A completely different situation exists if the tile obtained on the first draw is not returned to the box before the second tile is drawn. This just changes the probabilities on those second branches. So you can see here we have an entirely different tree. The first branches still have 3/7 and 4/7. But now when you look at the second branches, you'll see that the probabilities have changed. When we look at the top branch, there are now 6 tiles and only 2 of them are red. When we look at the second branches, There's still 4 green tiles, but only out of 6. When we look at the third branches, there are still 3 red tiles because we pulled a green, and there are only 6. And then at the very last branch, we now only have 3 green tiles out of our total of 6. So this gives us our probability tree, and you can see we compute our probabilities at the end. And notice the denominator here is different because these two events are dependent. The second draw depends on the first draw. The first draw changes the second event because we've changed the number of tiles. That's it. I hope this gets you started with activity set 8.2 and helps you make sense of working with probability trees.